You know, we hear the term artificial intelligence thrown around all the time, but let's pause for a second and focus on that second word, intelligence. Before we can even really talk about building it in a machine, we kind of have to figure out what it means for us.
So let's just start with that huge question. What does it actually mean to be intelligent? Is it about scoring high on a test, or is it something much, much deeper? This is the absolute core question we have to grapple with before we can understand what AI is even trying to do.
And here's why that's so important. To even attempt to build an artificial intelligence, we first have to get our heads around the incredible complexity of our own. It turns out intelligence isn't just one thing you can measure. It's a whole beautiful spectrum of abilities, and it's definitely more than just book smarts. Howard Gardner's theory of multiple intelligences just completely blows up the whole idea of a single IQ score. I mean, think about it. You've got the poet's way with words, the scientist's knack for logic, the athlete's sheer physical genius, or a great leader's ability to just read a room. Heck, even just understanding yourself, your own feelings and motivations, that's a super powerful form of intelligence. Every single one of these is a totally different way of seeing and interacting with the world. And right there, that's the fundamental problem that the pioneers of AI ran into. If we can't even agree on a single, neat definition for human intelligence, how on earth are you supposed to sit down and write the code for an artificial one? This challenge has literally shaped the entire history of the field. So how did they deal with that? Well, the fact that there isn't one perfect definition of AI isn't really a failure. It's actually a reflection of this really cool, ongoing debate among the very people creating it. And over the decades, they've approached it from a few very different and very interesting angles. In the early days, the goal was, well, it was huge. People like Hageland and Bellman saw AI as this epic quest to build a machine that could literally think like a person. The focus wasn't just on getting the right answer, but on recreating the whole internal process, the reasoning, the consciousness, the whole messy, wonderful human experience inside our heads. But after a while, that thinking started to shift. Ray Kurzweil's definition was a real game changer. He basically said, hey, let's forget about trying to replicate the feeling of thinking for a minute. The important question became, can the machine simply do the intelligent stuff? You know, if a person needs intelligence to play chess, and we build a machine that can play chess, then boom, that's AI. The results started to matter a whole lot more than the process. And this definition might be the most practical one of all. Rich and Knight basically define AI as a moving target. It's the frontier of whatever computers can't do yet. You know, back in the day, that frontier was chess or recognizing a cat in a photo. Today, it's writing poetry or generating code. So in this view, AI is simply whatever humans are still better at, for now.
Okay, so this journey to define and build AI, it has been anything but a smooth, straight line. It's actually a really dramatic story, filled with these incredible breakthroughs, followed by massive hype, and then these periods of just crushing disappointment. It's a true roller coaster ride.
I mean, the early days were so optimistic, with these huge ideas like the Turing test in the 50s. By the 1980s, that optimism exploded into a commercial boom with these things called expert systems. Companies were pouring millions of dollars into it, thinking true AI was right around the corner. But the hype just got way, way ahead of the actual technology. The promises were gigantic, that the machines just weren't there yet. And that led to a massive crash, the infamous AI winter, where all the funding just dried up and the field nearly died. It really took a whole new generation of thinking and, frankly, a mind-boggling amount of new computing power for AI to come roaring back in the mid-90s. And that kicked off the incredible era we're in right now.
So after all that history, where are we now? Well, a common mistake people make is seeing AI as this direct competitor to us, like it's a battle for who's smarter. But that's really not the right way to look at it. They're just fundamentally different kinds of intelligence, with totally different and often complementary strengths. Think about it. Our human intelligence is creative, it's inspired, it's adaptable. It learns from a whole lifetime of scraped knees and smelling rain and all of our sensory experiences. AI, on the other hand, well, it's not creative, but its knowledge is permanent. It doesn't forget. It doesn't get tired. You can copy it a million times and send it around the world in a second, and it is relentlessly consistent and unbelievably fast. The key thing here is that one isn't just a better version of the other. They're built for different jobs.
Okay, so we've established that AI isn't really a replacement for us, but a different kind of tool, a super powerful, fast, and consistent one. Which of course leads to the next big question. What's actually going on inside the black box? How does an AI work?
All right, let's pop the hood and take a quick look inside.
And don't worry, we are not about to get lost in a bunch of complicated code, I promise. But we are going to look at two really basic concepts that are pretty much the building blocks for how an AI system reasons its way through a problem. First up, you've got this idea of heuristics. And honestly, the best way to think about these as rules of thumb. You know how an experienced chef doesn't need to measure everything to know a soup needs more salt? They just know. They're using a heuristic. AI does the exact same thing. It uses these programmed shortcuts to solve problems way more efficiently, without having to start from zero and reanalyze every single possibility every single time. It's how it stays smart, but also fast. And then, second, you have inferencing. So if heuristics are the quick and dirty shortcuts, inferencing is the engine of pure logic. This is how an AI connects the dots. It takes facts and rules that it already knows, and it combines them to create a totally new piece of information. For instance, if an AI knows fact A, Socrates is a man, and it also has rule B, all men are mortal, it can then infer a new conclusion, conclusion C, Socrates is mortal. This simple process is the absolute core of how it can reason. And all of this brings us full circle, right back to where we started, but with a whole new way of looking at it. See, in our big quest to build machines that can think, we're actually forcing ourselves to ask much deeper questions about us. If a machine can learn and reason and adapt using these logical tools, then what is it that makes our intelligence so special? What's our secret ingredient? And that's the really profound question that this incredible technology forces every single one of us to think about.